Good to talk to you now about vacuum forming. What we're going to do is we're going to make a plastic case for our little PCB. It's going to look a bit like this. Okay, so a single one of these. And we're going to use this plastic here called high impact polystyrene, or HIPS, to do that. So the way this machine works, and we'll show you as we go through, this section at the back is a heater. We have a section here which has a bed. We have lots of different little moulds here. Now these moulds we're going to use for the plastic to form over them, and we're going to have this section here which is the base. We're going to form it over the mould and the base, remove the mould, and then be able to use that to make our cases. So the way this process works is we line up all the moulds on the bed, and I'm going to put them this way around, space them nicely. Now it's really important to consider when we use plastics to make sure we're as efficient as possible and not to waste any material wherever possible, because obviously plastics are made from crude oil usually, and therefore being efficient with it is really useful. So I've used as many moulds as I can in here to make sure it works properly. We then use the handle down the side to drop the bed very gently. It's quite a lot of weight, so we drop that bed very gently and then let that rest against the bottom. We then pop our high impact polystyrene on. We've got a shiny side and we've got a matte side. We're going to put the shiny side up and we're going to close this down. And what this does, as we clamp this down, that creates an airtight seal within that chamber, and it means we can remove the air later. So I'm moving the heater over the top of the plastic, and you can see the heaters are on here. This is where the thermostats checking how hot all the different zones are. And once it's hot enough, we're going to just move it backwards. This plastic will start to heat up, and it will start to sort of warp as the top side heats up faster than the bottom side, but then it will become more pliable, more malleable, and as its plasticity increases, it allows us to drape it over the moulds, and then as you remove the air within the chamber, it will then suck those moulds, suck the plastic down over the moulds completely. This process is widely used in a variety of different things, most commonly yogurt pots and things like chocolate trays that you get inside a box of chocolates. Just check our material. Obviously it's quite hot, but you can see how that's quite bouncy now. So I'd recommend not using your fingers to do that, but just use a pencil or something with a blunt end on it so we don't mark the plastic. We're going to talk about the moulds in a second. The moulds we use have an angle on the side. We call that a draft angle. That draft angle is to make sure we can remove the mould afterwards, which allows, so if the angle of the mould was too straight, the friction inside that mould would stop that mould from coming away. So we have to make sure that that draft angle is there, and also all the edges are rounded to make sure that the mould doesn't pierce the plastic as it gets moulded over. So I think this plastic is just about ready. So I'll remove the heater. I'm going to push the moulds back up. You can see them pushing against the plastic. I'm going to flick the vacuum pump. And that just removes all the air, and you can see that the plastic has now been drawn around the moulds correctly. So that will then need to cool down. What I try and do with these moulds is I try and remove them while the plastic is still a little bit warm. It allows me to sort of move the plastic so I can get the moulds out without too much difficulty. And then I will trim around them and then start to make the holes in it for our components to stick out of, things like our switches and our LEDs. Okay.